we want to review some information before we get into actually solving inequalities. And so the first thing I want to do is look at some different ways of representing sets. Um, so we're going to look at set builder notation as a way, interval notation as a way of representing a set, and then also looking at drawing the set of numbers on the number line. So let's look at some different sets. So we'll start with something like this. We're looking at sets of numbers such that those numbers are less than 3. So if I want to look at that, let me go over and draw the graph. And I'm going to show you two different ways you can draw the graph. And when you're drawing these graphs, just kind of focus on the numbers that matter. So in this case, the number 3 is what's important. I'm not going to worry about 0, 1, 2, and 3. I'm just going to label 3 here. And I'm looking for, this is saying I want numbers less than 3. So one way I can do that is I can draw an open circle here at 3. And I want to shade every number that's less than 3. So I'm going to start shading all this stuff over here. But you're going to notice I'm not going to shade the circle because 3 itself is not less than 3. So 3 does not satisfy that expression, but all these other numbers do. 2.9, 0, negative a million, everything that way. So that's one type of way you can draw it on the number line. The other way is to use a parenthesis, and that would indicate that 3 is a boundary but not part of the set itself, and then you would shade that way. So the parenthesis is the same as the open circle. It's just another way of doing that notation. Now, how interval notation works is you're looking at this graph and you're saying, okay, well, what numbers am I shading for? And if I want to read it left to right, so how far left does this theoretically go? And it goes to negative infinity. And then how far up does it go? It goes to 3. But I want to indicate that it doesn't actually get to 3. So what I do is I put a parenthesis on that side of my boundary of my interval. And since I can't ever actually get to negative infinity, I want to put a parenthesis on that. Infinities are always parentheses because you can't ever actually get there. So the idea here is interval notation is supposed to make you think of this second graph. You're going from negative infinity up to almost 3. So let's look at a few more. Let's say we had x was greater than or equal to 5. In this case, again, I'm going to show you two different ways of doing that graph. So again, I'm just going to label the number that matters, in this case 5. And so just like in this first example, I'm going to draw a circle on that number. And now I'm looking for every number that's greater than or equal to 5. Well, that means I want everything now to the right. But since it says I can equal it as well, then that means I can shade inside that circle as well. Because now I'm given the option to equal it. So whether this is a solid dot or an open dot, a clear dot, depends on whether we're saying it can equal that number or not. So in this first case, it was not equal to, that's why I left it open. The second case, it was equal to, so that's why I shaded it in. The other notation you could use, the same idea, I'm looking for numbers to the right here, but at 5, I want to indicate 5 is actually a potential answer. So what I'm going to do is I'm going to use a bracket to indicate that is actually one of the answers to this problem. And so if I want to do interval notation, I want to say, well, what am I shading? Well, I'm shading everything from 5 up to positive infinity. So again, infinities are always parentheses, you can't ever actually get there. But in this case, I want to say 5 is an answer. 5 is greater than or equal to 5. It's equal to 5. That's an option. And so, it picks up from 5 up. All right. Let me do one more of this notation here. So let's say x such that x is less than negative 1, or x is between 3 and 5 but not including 3, but 5 is included. So it's greater, x is greater than 3, but less than or equal to 5. So if I look at that and say, okay, well, what would that look like on the number line? So here, so -1, 3, 5. And again, I'm not really worried too much about the scale here or anything. Just kind of get an idea what this looks like, putting things in numeric order. So, if I'm going to use the circles, what I see here is, okay, the 5, the value I can look for could equal 5, so that one's going to be a solid dot. But these other two are going to be open. And then I want numbers less than -1, so down here, less than -1. And I want numbers, physically between, I want these numbers physically between 3 and 5, so I want them in here, in this area. Okay, so now if I want to use the parentheses and brackets, this would be a parenthesis going that way. Okay, and then this would be a parenthesis, and this would be a bracket. You gotta go this way. So you can kind of see why, like, some people might not like the parentheses and brackets. You kind of have to decide which way you're going before you draw them. Whereas the circles, you can just draw the circles and then figure out which way am I going. Interval notation, again, you always start how far left does it go. So -infinity, and continue on until it gets to -1. Doesn't actually get there though, it gets close. Union, that means or. You can be over in this area or you can be over in this area. Just past 3, so parenthesis at 3, to 5, and you actually get to 5. So there it is, interval notation. So that's a little information about these different types of notation and graphing. Now another thing I want to touch on is the difference between and no. How we use the word and and or. How do we use the words and or in mathematics? So I'm going to look at 6 different kind of situations. I'm going to look at them for and then I'm going to look at 3 of them for and then I'm going to look at them again for or. So let's say I have x is greater than 3 and x is less than 5. Okay, and then I'm going to say x is greater than 3 and x is greater than 5. And I'm going to look at x is less than 3 and x is greater than 5. And I'll say, okay, what's going on here? What's the difference between these 3 different situations when we're looking at the word and? So I'm going to look at them in the number line. 3 and 5. Okay. So when we talk about and, what that means is both must be true. So on the number line, what that means is where they overlap, where the two things overlap. So if I say I want x is greater than 3, I say, okay, x is greater than 3, that's that way, right? And I say, well, x is less than 5, I'll go that way. What I want to know is where they're both at. Where is x bigger than 3 and also less than 5? And what I see is it's in this middle area here. So this way of writing this answer is 3 is less than x, which is less than 5. X is between 3 and 5, physically between those. So let me look at this second case. So again, we have x is greater than 3, so going that way. This time we have x is greater than 5, so going that way. And the question is, where is both of these at? And the answer is it's over in this area is where both are at. So this answer, simplified, is x is greater than 5. So if you're looking for things that are bigger than 5 and bigger than 3, well, that means you really just want numbers bigger than 5, because if they're bigger than 5, they're automatically going to be bigger than 3. And then this third situation, now we're saying x is less than 3 and x is greater than 5, and we're looking for overlap, well, there is none. There's no overlap here. Um, no solution. Right? No solution there. They don't overlap at all. There's no number that's less than 3, and that same number is greater than 5. So this statement doesn't make sense when you're looking at and. Now, if we compare that to or just means at least one is true. That's what or means. Or it doesn't say that they both can't be true. They both can be, but at least one of them is true. So let's look at those same 3 relationships, but this time we're going to look at it from the perspective of or and how that's different. That gives us a different answer for these. So again, I'm just going to go through 3 and 5. 5. 5. So in this case, I'm going to say, x is greater than 3, or x is less than 5. Well, where is that at least one of them true? Well, x is less than 5 here, or I should say, or x is greater than 5 here. Well, that is all real numbers. So x is an element of the real numbers. All real numbers, another way of saying that. If you want to use interval notation, you can say it goes from negative infinity to infinity. That's another way of saying all real numbers. All right. So at least one of them is true everywhere. Now there's some that are true in the middle that are true for both of them, but that's not a requirement for the word or. Or just requires at least one of them is true. And in this case, everywhere at least one is true. So now let's look at the second case. X is greater than 3. X is greater than 5. So where is at least one true? Well, starting just past 3, this red one's true, and it, also once I pass 5, both of them are true. So this answer is x is greater than 3. So notice the difference between this one and the and. And is, the more, you might think, the smaller set. There's some numbers that are bigger than 3 that are not bigger than 5. So we're going with the more restrictive set and because we're looking for which one is, both of them true. In this case, we're looking for the bigger set. Since, there's some overlap going on here, we want all the numbers that are bigger than 3 as well as all the numbers that are bigger than 5. So, there's a distinction between this and this or situation. Then let's look at this last situation. And I would say this last one's more typical of what you would run into in a problem with or. Though you can run in the other situations as well, but this is the more common one. And the answer here is, well, x is less than 3 or x is greater than 5. Just exactly like this was written originally, this answer, there's no overlap. So, part of your answer, there are numbers down here below 3 that are part of your answer, and there's numbers bigger than 5 that are part of the answer. This bottom part satisfies the first expression, this top part satisfies the second expression. Or says it's at least one of them is true, and so the only numbers you can't pick is anything from 3 to 5, including 3 and 5 would not work. But other than that, any other number would work for that.